Hello everybody, hopefully you can hear me, and thank you very much for inviting me along. As Richard was saying, usually we get together and it's great fun to meet and talk. So when we get to the end of my presentation, yes, there's questions, but I'd like discussion because we're a mixed audience. Some people, well, some of my friends here saying, oh, right, well, okay, Andrew, you keep going on about these Stirling engines. Maybe we'll listen in just to find out what this thing is that you keep going on about. But at the other end of the scale, there are people with huge amounts of knowledge, I suspect, in the audience tonight. And I'd like to ask them a few questions. Maybe some would ask me, but I too would like to join in and have a discussion. The Stirling engine has been around for a good 200 years. It's an engine. It's been used for all sorts of things. There was a record player, the Palliard record player, ran on a Stirling engine. Then there was also, I'm told, Stirling engines pumping air in churches so that the organ didn't have to have somebody working a bellows. It was driven by, the air blower was driven by a Stirling engine. So over the 200 years, the engine's been used for nearly anything and everything. And of course, nowadays we're surrounded by engines of different types. So we tend to use the best engine that's for the purpose. I have an electric toothbrush. You have an electric toothbrush. There's a specialist little electric motor in there. Next door to me at the moment, there's some builders working and they've got a special motor for doing up the bolts on the scaffolding. So it comes around to what is an engine best at, and let's use it for what it is best at. So I found this rather nice quote going back to 1903, and whoops, I pressed the wrong button. I shall press another one. There we go. And this is 1903. I'm hoping that you can all see a large green pointer. If you can't, or something goes wrong, please let me know, maybe by telephone to my wife here, I don't know. Anyway, in Kentucky, the Sisters of Loretto, maybe they were nuns, I don't know, but they wrote a letter to a producer of the Stirling engine, which you will know all about, and they've had it for 15 years, and it has given entire satisfaction. And the special features are that there's very little fuel needed and it makes very little noise. So back in 1903, this engine was standing out as reliable, efficient and quiet. But today's needs, we've got another couple on the list. We don't want to be poisoned with carbon monoxide or baffled with nitrous oxides. So there's an engine which has been around a long time, and let's have a look at it. Because this was a lovely leaflet, a sales leaflet, produced by the Ryder and Ericsson company that made the pump, the water pump, that the Sisters of Loretto were writing about. And inside, those of you who know the museum well will recognize this, because this is the Ryder engine, Mr. Alexander Ryder, and it was used for pumping water. And of course, back in 1870, times of that sort, mains city pumped water was not widespread, and if you lived on a farm you had to have a well or you couldn't live there, and you needed water for the cattle as well as yourself. So if Mr. Ryder or Mr. Ericsson came along and said, look, if your servant can light a fire, euphemism for slave I suspect, if he can light a fire, then by the time the fire is burnt out, this engine will have filled the header tank for the day, and it will be a lot less effort than cranking away on a hand pump. Going on further on in the catalogue, this is the range of the Ericsson engines, John Ericsson, and they came in various sizes. And I've seen a serial number for the engine above 15,000. So I reckon they probably made and sold about 20,000 of their engines. So I think that's a success in anybody's book. So that was one of the usages that they have been used for. And then round about just before the war, so last war, 1935-37, I think, the Phillips company, they made an engine, a Stirling engine. It was a portable. So this is the carry frame. And there was a pull string. Can't see it on this side. Maybe it's on the other side to get it started. And they wanted to make electricity so that you could power a radio. And of course, it being a relatively quiet engine, silent engine, you could hear the radio, not some large generator set making a lot of noise. Engineering-wise, it was a great success, but not a commercial success, because in 1950-something, there was the invention of the transistor and the tranny radio. So there wasn't a need for a generator. You could run it off a battery. So that's one of the usages that didn't quite make it. But what Phillips did discover was that you could work this thing backwards. This is a reversible engine. We're used to the idea that you put coal and heat into a steam engine and the wheels on the train, on the engine, the railway line work. With this one, similar sort of game. At this end of a cylinder, you put in heat. And yes, there is a piston. I'll come back to the displacer in a bit. And the piston pushes the wheel. You have output. The motion is the output. But if you flip this around and you spin the wheels and push the piston in and out, heat is taken in. Well, when it's the engine up here, heat is taken in and the wheels turn. If you turn the wheels, heat is taken in. There isn't a source of heat here, so it'll just make things very cold, extremely cold. And you can actually make liquid air or liquid nitrogen. So here is a film from Phillips, probably about the 60s or the 70s. And this is what they call the cold finger. And you can see a line of frost here. And all this vapor is coming off. And there is liquid air, well, liquid nitrogen pouring out. I'll let this one play again. You can see a frost line develop and then move down as this thing gets colder and colder. So, and here we come. There will be liquid nitrogen coming off in a moment. So why on earth do we want extremely cold temperatures? Well, it's the cryogenic industry. And Heston Blumenthal might be using liquid nitrogen to help him serve his food, but we want cold temperatures for things like magnets, because you can make a magnet work far more well, an electromagnet, if it is chilled down. It's called superconductivity. And if you chill a magnet down, or the electromagnet down, you can get huge currents flowing, the superconductivity, and a hugely strong magnet. So Phillips really triggered and kicked off the cryogenic industry, and I'll talk a little bit longer about that later. So that was what's in the past. We've had 20,000 odd pumping engines for pumping water, and we've had the cryogenic industry, well, given a great boost by Phillips. What's it used for now? Well, we still want electricity. This engine, yeah, there are fins up the top there, and that's where the flames are. And there's a water circuit here, and the water cooling keeps one end cold. The flames keep the other end hot. There is a piston down here, but this is a coil, and that's where the electricity is made. So it's actually domestic heat and power. So your central heating boiler could be replaced by one of these. Yes, you're burning oil and gas, and that makes heat, but we can also have a Stirling engine in there making some electricity. It doesn't make a huge amount of electricity, 1 kilowatt, but if you've got 20 million households in your country, the government gets interested in 20 million kilowatts. So Germany, for example, put in a subsidy, and some 10,000, maybe more, have been installed in Germany. And Microgen tell me now that it's nearer 20,000 of these engines that have been installed for combined heat and power. So that's a current use now. So in some ways, I think this is even more popular and more successful than the Ryder and Ericsson engines. So here's another shot of the Microgen engine, but this one is being used by the firm called Ocofen. And they're using wood pellets to create the heat. So people are using the engine for other purposes. And here again, this is a firm called Ultracool. And again, they're using the reversible business of, if you put heat in one end, you'll get motion out the other. But if you bounce this up and down, courtesy of an electric magnet, it's a linear motor, that piston will go up and down, the springs will spring, and you'll get heat taken away up here, and it will get cold. Their usage is for -80 centigrade, and I think they're trying to move transplant materials or medical supplies around. And you can even plug it into the cigarette lighter on your car, so a usage. But looking back, this is the same engine basically, but driven or driving. It's reversible. And I've got a video now of the thing as a cut through. And yeah, what on earth is going on here? Well, the red bit is the piston. And these are springs. The black bits are springs. So given some heat up this end, then air expands and pushes the piston, but I will talk more about how this thing works and what Reverend Robert actually invented back in 1816. But there are only two moving parts in this thing. There's this bit, the displacer, I will come on to that, and then there is the piston and the springs. So maybe it's four moving parts, but that's where the reliability comes from with the Stirling engine. And here are the two wires coming out for the electricity. So let me actually get around to what on earth is going on inside this engine, and what Reverend Robert back in 1816, a year before, Napoleon and Wellington had been having an argument. But meanwhile, the Reverend Robert was taking a tin can, a cylinder, putting a piston in it, and if you stick a flame under it and heat all this, then the molecules inside get very excited and start bouncing around with great vigor, and they push the piston out, and you can put a wheel on the end. It'll only do half a turn because it's pushing it out. Then, if you take the flame away and pour cold water all over the thing, it takes time to cool it down, but inside the molecules will get less hot, they will become less energetic, and the molecules out here at the ambient room temperature will have more vigor and will push the piston back in. So we've got an extremely slow engine here. It takes about 3 or 4 minutes to heat something up, and then you've got to cool it down, and then your piston will come in and go out. So the Reverend Robert had a good idea and said, how can we turn this into an engine? And I think, this is my speculation, he was 25 when he did his patent. It was probably about at the age of 15 and all the rest of it, he would have seen the wash tub and the clothes getting washed. So there's the tub, hot water and clothes and soap would go in there, and then the posser, or the dolly, or the posh would be pounded up and down like a plunger to agitate the water and get the water moving around the cloth. So I think he used that idea on the cylinder with the piston, because this plunger, and Reverend Robert did call it a plunger in multiple, many of his patents. I think the word displacer came along later with the academics maybe, but this plunger goes up and down, in and out, inside this volume. So if we have a flame at this end, and cold water at this end. That end is hot, this end is cold, and the plunger moves the air up to one end and then back to the other end. And when it's here, it's hot, the piston gets pushed, and when the air is there, it's cold, and the piston comes back in. So that displacer or plunger, I don't know if it did any other devices really, other than the wash tub. And then he thought of another idea, and really I think for me this is why he is famous and why he is duly given a lot of respect, because well, and I speculate that he called upon this idea from his personal experience, because as a young lad I can hear his mum saying, "It's cold out there, wrap up well, wrap a scarf round your face so that when you breathe out, the hot air goes out, but it warms up the scarf. And when you breathe in, cold air comes in. Scotland is rather cold in winter. The cold air comes in and is warmed slightly by the scarf and then goes down into your lungs, pre-warmed. So the heat in the air is saved on your out breath and regenerated on your in breath." So I think he knew from personal experience about a regenerator, and what he did was to take that diagram. Here's the cylinder, there's the piston, and here's the plunger or displacer, and he literally wrapped wire, thin wire, around the displacer, coiled it. So when the air is going that way, it starts hot, it loses heat to the, not the scarf, but to the wire wool, the wire cables in there, and comes out cold. And then we really chill it by some cold water. And when it goes the other way, the air goes, cold air goes in and picks up some heat and winds up pretty warm, and then we top it up. So the regenerator for me is probably a fancy sort of scarf. Now, whether this is got any sort of hope of reality, well, I don't know. It's my speculation. But there's the engine, and there's a hot end and there's a cold end. And when the air is down here, it's hot and it pushes the piston. And when the air is up here, it's cold and the piston is pulled back in. And it's just the same as the design of I showed you earlier with the ultra cool and the microgen engine. Let me just have a little talk about the patent itself. As I said, the year after Waterloo and 1816, and the title of the patent, this is the first of the patents, was for improvements of diminishing the consumption of fuel. So what was in his mind was that we could get engines to run more efficiently using less coal. And it can be applied to the saving of fuel in breweries, distilleries, dye works, and other manufacturers. So what was in his mind, because if you look up things on the web, you will find occasionally references to the idea that him being a man of the cloth, Reverend Robert Stirling, was horrified at the death of his parishioners from steam engines. Well, he was a bit futuristic, because the steam engines weren't blowing up in large numbers for another 50 years. The worst one was the Sultana boat on the Mississippi. And they had, it was built for 400 people, and it was a civil war, and they put 1,800 prisoners of war on it. And the engineers down below thought, well, we better get a bit of steam up, because this is a hell of a weight we're going to have to shift. And the damn thing blew up, and 1,800 were killed. So, but that was the peak of the deaths by steam. But that was 50 years later, 1865. And there was also suggestions perhaps that maybe he was trying to dodge Boulton and Watt's patents about the condenser and other things, but I'm not sure on all the patents there, but the one that about the condenser lapsed in 1800. So if he was trying to do that, he was a bit late because it was 16 years later. And his patent is clearly stating that he's about economizing the consumption of fuel. And Reverend Robert did actually call the regenerator and the engine, he called it the economizer. That was his term for it. So I think the word regenerator came in later, maybe with some academics, and likewise the term displacer. Anyway, that's what's been going on. And of course, what's happening now is the microgen, which is perhaps 20,000 engines in use in various countries, and also the cryogenics, because yes, we can use low temperatures with superconductivity, but it's about imaging, a magnetic resonance imaging, an MRI scan, wants a scan, an image, and for cameras to get ever more detailed images, this is electronics and photons and, blimey, physics. So to get that level of signal accurately and clear, there's a problem called the signal to noise ratio, because it would be good to, I've just noticed I've got the consumption of fuel. Maybe I've misspelled that one. He wanted to, with the cryogenics, the imaging needs clear, crisp images. And if you lower the temperature, random electrons don't cause noise in your signal. So if you want imaging, high quality imaging, like a heat-seeking missile, you need a Stirling cooler up the front to get a good image so that the navigation can home in on the target. So the military are in there with the Stirling cycle, and it's there for other cooling purposes. Along the motorways, there are repeater towers, poles with repeating signals for our mobile phones. They've got coolers in. We've managed to get hold of one, and of course it works on American voltage, but we did manage to get it down to -40 centigrade. So there are lots of cooling applications, and so the now usage is the combined heat and power, microgen, and the cryogenic industry. But what's coming? What's coming down the line at us? Well, we still want electricity, and we want it in remote places, and you can't get much more remote than the moon base or Mars, the Martian base. And of course, NASA are getting, well, they've got a planet before they build it, before they go. And they have made an engine, they call it kilopower. And this is the core of it. In there is a Stirling engine. In fact, there's 4 of them. And down here, well, I'll go to the schematic because it's a bit more interesting. There's the Stirling engines, 4 of them. Down here, there is a nuclear fission core radiating heat. So that's one side. This is bouncing up and down, making electricity. And the other side you want cold. And of course, the deep space is extremely cold. So that's rather good. This is rather good for a Stirling engine. One end's nice and hot, and the other end's nice and cold. And NASA have gone and produced this. And here's Mr. Sal Oriti of the Glenn Research Center for NASA. And he was interviewed. And one of the magazines took some notes on it. And it is executing the free piston Stirling cycle. Yeah, well, for those of you who are into Stirling engines, you might have noticed that I've not talked about the 3 major types of Stirling engine, A, B, and C. I'm not really going to, because what I want to talk about is what they're good for and what we're using them for. And the free piston Stirling cycle is one of the, we think there's about 40 variants. The Fluidyne is a lovely engine, but we haven't got any commercial use for it. But this one, the free piston Stirling cycle, it's the one making electricity for microgen and making cold temperatures. So What Sal is saying is there is two moving parts in there. You saw them wobbling about. There's no contact between the moving parts. We're used to axles in ball bearings and pistons sliding. There's no contact. Down here, there is no friction because these things do not touch. And down here, well, I showed you some springs at the bottom that bounce things up and down. You can flex those springs infinitely, forever. Excuse me, I'm just for an infinite number of cycles. Now, wait a minute. This is an engine that runs continuously because NASA have tested it. They've had 14 years of continuous running, and it's still running. If you've got the heat, it will run. And it's had no maintenance, and it's been running continuously for 14 years. There's no contact between the moving parts. There is no friction, and you can flex those springs forever. So, good heavens, an engine that does not wear out, and it runs forever, and you can run it continuously. There's no maintenance. I think this is pretty amazing stuff. And you know, it suits NASA fine because they want to do 20-year missions out into deep space, and they've committed to using Stirling engines to make the electricity. But when the trickle down occurs from the space race to planet Earth and you and I, maybe our engines will start having air bearings and precision so that things move past each other but don't actually slide and grind and wear each other out. So I think that's probably going to get taken up very strongly. I hope so. Poor. I've been through 200 years of Stirling engines in 25 minutes. What are we doing back on Earth? Well, I'm having fun with boats. And that's my friend Adrian. And this is his sister, Linda. And they're using LPG, which is very nice and cheap. And there's a Stirling engine. This is the burner up there. And we've got water coming in and out from the river, keeping things cold. That's the water jacket. And it's a nice application. We don't have the cold of deep space, but we have 400, 600 centigrade of burning LPG. And this is an extremely well-behaved engine, reliability. The one I drive is over 20 years old. And this particular engine came from Cambridge University. It wasn't intended to be an engine. It was actually to allow people to measure temperatures of gases and pressures and things. But Adrian got it going again, and it's pushing a boat very nicely. And every year I've been holding a rally. Here's Adrian with his boat, and this is me here. And this is a 25-year-old engine, 20 plus. And it's actually 3 engines. You can see 3 cylinders here. And it's reliable. These things are very easy to start. I've spent too much time walking down to the riverbank with a toolbox in one hand and a petrol can in the other. And I look at my watch and I say, well, the family and the kids will be here in an hour. I hope I can get it started by then. With this one, you need a gas bottle that's got some gas in, and hopefully you didn't leave it empty, so there's probably gas down there. And you need a lighter, a clicker it's like lighting your gas hob in your kitchen. So once you've done that, you wait a few minutes for heat up because it's like cooking a piece of toast. It takes time for the heat to get going, and then off it goes. So we have a rally. We didn't have one this summer, but if you have a look on our website, that was the 2019 rally. So here's the website, stirlingengineboats.com. It's almost turned into a chant for me. So we have a list of all the rallies. We go back to about 2012, I think, maybe. And we've got a list of the fleet of boats. the long thin one that I talked of Adrian and his sister, that's Regen. The one I drive is called Stirling First. So we've got about 6 or 8 boats. And yesterday I had a nice email from Bob Atkins. I think he's in Australia. And he sent in some video of the boat that he's got. So we've got a fleet of about 6, maybe getting on for 10 boats around the planet, because it makes sense to push a small boat with a Stirling engine. The Stirling, I've even written a book in my lockdown period. So the 10 of us in the UK have been taking engines, putting them into boats, having successes, having failures, and I've tried to record that on this online book. So if you want to have a look, there's quite a lot there. I haven't had 2,183 people read it yet. I started with the counter at 2020. So I'm at 163 people who have been reading it so far. But boats and Stirling engines are not new. That man Ericsson, John Ericsson, he invented the monitor in the American Civil War, scared everybody. 1853, he built this thing, 250 foot long, and a monster driven by a hot air engine, or a Stirling engine. John Ericsson definitely knew about regenerator, and maybe that's the key component that defines a Stirling engine, that it's got regenerator in. If you're just heating air and cooling it, maybe it's just hot air, cold air engine. But John Ericsson's quote is that bundles of wire are worth shiploads of coal. And when one of the Navy commanders was sent along to inspect the Stirling ship Ericsson, he commented that there was very, very little bunkerage. There was no room, they didn't have to have any coal at all. It's very efficient. There'd be plenty of room for more guns and bombs. That's the military viewpoint, I suppose. Anyway, looking at this boat, he had 4 engines in there. And this is more or less to scale. The pistons were about 6 feet wide, and they went up and down about 8 feet. And there's the bit that moves the air, and this is the bit that eventually turns the paddle wheels through the connecting rods down to the piston. So John Ericsson started with that monster boat, and others have followed suit. I talked about the Phillips company, and this is one of the things that inspired me a bit. Here's a nice little boat, they called it Hunt. You can see the engine in the middle with a tin can on the front top because there's no vibration. They're very steady little engines, they don't bounce around outside. And they also built a 30-footer called Yander Wit. 30 horsepower? Something of that sort. So there's quite a long tradition of Stirling-powered boats. And with our rallies over the last 10 years or so, we've been taking engines. Julian Wood's been making them, Norris Bomford's been making them, Malcolm Rowney's been making them. We fit them to boats and we begin to learn things. And one of the things is, how do you control the speed? Yes, there's a top speed, but how do I go at half speed or even slow down? One of the things we innovated or maybe applied is the idea of a kill tap. There's the green displacer, there's a black piston, here's the water cooler, this bit's hopefully got flames on the outside, and there's the regenerator. And if you take a pipe from there down into the crankcase and then put a valve on it, if you open that up, then all the pressures are equalized and your engine stops. We call it the kill tap. If you half open it or half close it, then you go half speed. So we've been applying that to, I think we've got it on 3 of the boats now out of the 5. And I was looking at the patent yesterday or the day before, and way up the back end of the original patent, there is one sentence which says, the engine can be regulated by a valve to vent the air. And yeah, Rev Robert knew all about it. He'd got that in there as well. But another thing we learned on, again, it's speed control. This is the boat I drive. there's the propeller. And well, I've got two rudders there. Now, a rudder, you pull it one way and you, like that, and you turn to the left or the right, depending which one you pull. But if you pull both of them slightly, you spoil the thrust of the propeller and you go slower. And if you do a blank wall at it, then you can stop the boat. So we've had a couple of innovations. And Norris, Norris Bomford has been in this game longer than most of us. He's on the cover of Motorboat and Yachting, 1976, with his first engine. He's still at it. I'm driving one of his. He gave it to me to use, and it's got 3 engines here. You can see the tops of them, and I can only just see over them. I took this photograph. And here's Norris's latest engine, which is just a single cylinder, and it's a lot lower. There's Mike Ritchie. Maybe you're tuned in, Mike, I don't know. But so a lot lower, and with just one cylinder, it's developing the same power. These two boats, it's taken from video this, these two boats are going at the same speed. So Norris has evolved things from 3 large cylinders down to 1. And one of the reasons that's been possible is because he's pressurized it, turbocharged it. If you want to have a more powerful Stirling engine, you want more hot molecules of gas pushing at the piston. So let's have a bigger engine. We'll have more gas molecules in there. No, 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 no. What you do is you get out your bicycle pump, and we have done this, and you pump more gas molecules into the engine. So instead of having a big engine with a large number of molecules, you take the same number of molecules, but pump them into a smaller engine, a pressurized engine. If you double the pressure, you've got twice as many molecules, and you should have twice the power. Theory is marvelous. So we keep on evolving our engines, and there is the fleet, and I'm at 35 minutes, so I ought to be stopping. So there's Norris's engine there, which is smaller than all the others. Adrian's, Malcolm's, Julian's, and Norris's one that I use. So maybe I should come to an end, and but you should join the Stirling Engine Society, you know. There's 100 or so of us in the UK, and we have a newsletter, and we email each other, and we've got websites, and yeah. So you can join, £15 a year. I've got to do the advert at the end, but just get online to stirlingengineboats.com. Thank you very, very much, and I look forward to having a bit of a discussion now. Can I hand back to Kathy?
Thank you very much, Andrew. That's absolutely fascinating. I'm going to ask anyone if they have a question to submit it via the chat. I think that's the best way of managing it. The people on the phone, I'm not quite sure. Maybe we can take questions later. But so any questions, just please send them on the chat.
I would like to ask, where did you get your big rider engines from in the museum?
We were very fortunate. There are 2 of them. The half horsepower actually was gifted to the museum by a local resident about 16, 17 years ago. And it was a house which still exists on the edge of Hereford. It's a, I don't know, 10 bedroom sort of size residence. And this was in a shed in the grounds and was used to take water from a well through to the house. So we've got very good provenance for the half horsepower engine. The larger engine is actually on loan to us from the National Trust and has been for the last 10 years. Which we're extremely fortunate to have. It came from Taplow, on one of the residences adjoining the infamous Clifton estate. So it's not not of the houses of ill repute on Clifton, but one of the neighbouring properties, and was used for very similar sort of usages, particularly keeping a well-structured Italian garden, well watered.
Presumably it was a rather deep well, because Cliveden is up a sort of 50, 80 foot chalk cliff.
Yes, I don't know that I've seen the diagrams which suggest it was quite a depth. I mean, there is information on our website that covers this, but I'd be quite happy to circulate something that, because I think it goes to show the diversity of use of these engines at the time. And in a way, it's a great pity that they had such a short life, relatively speaking.
Right, we've got a question here from Lisa. The picture of the Ericsson engine shows two people standing on the pistons. Would that really have happened?
Yes, it did, I am told. The newspaper reports, if you start looking up American newspaper publications archives, some of us do, I think it was the Scientific American had quite a lot of coverage. And dear old John Ericsson was a publicist, a self-publicist, and he actually invited the press along. And the story goes that, yes, he invited people to stand on the pistons, which went up and down, not very fast. I don't know how many RPM. Does anybody know how many RPM?
It conjures up quite a nice image, I must admit.
Kath, John Wynne here from the Stirling Group. Can I just make a comment, please?
Sure. Go ahead.
Thank you. Andrew's given a tremendous talk, but I think an even bigger achievement for Andrew was that he managed to get his Stirling-powered boat to be legal on the River Thames. He managed to get a boat safety scheme certificate for that particular launch. Now, that was no mean feat, because the boat safety scheme executive had never come across a Stirling engine. And to Andrew's credit, he tackled it a step at a time and eventually managed to get a certificate which allows him and his friends to go on the river legally, on the River Thames legally. And I think that's a tremendous achievement, and one which should not be overlooked as something that's easy to do. It took a lot of hard work, and I think you should, it's real credit to him and his colleagues. Kathy, thank you.
I think they realised that I wasn't going to go away.
Well, I must admit, I'm not an engineer. Most of you will know that, and I found it quite fascinating to have the technology explained in nice, simple terms of scarves and plungers, because it makes it real. So I'd like to congratulate Andrew on taking what is a complex subject and giving a talk at a level that we can all engage with, and I found it highly fascinating and most illuminating. If there are no other questions, what I would suggest is if you finish the session and questions come to mind, feel free to email me, and I'll collate questions and answers and circulate them at the time we send out the link to the recording of the presentation.
Andrew, I have a question, if it's okay. I wanted to thank you for your very enthusiastic and informative talk. My question is rather general, and I'm sure you've thought about these issues. We often believe that the free market brings out the best. And in the competition between external and internal combustion engines, it is the internal combustion engine that has taken the biscuit. Why?
We're speed hungry, power crazed. Let me elaborate a bit. The Stirling engine has always been the poor man in terms of power levels. I think the biggest one was 400 horsepower. And I think Phillips or General Motors did that in a research laboratory. But if you get into marine diesels, you know, it's 40,000 horsepower. So it's a lightweight compared to petrol or diesel in terms of power. But we want some low-powered engines for low-powered requirements. So I think there's a niche, not just for boats, but for remote places as well. I keep on coming across applications to do with pipelines, be they gas or oil. And some of them need to be the electronic and erosion needs to be countered. So the cathodization is one of the roles, and others have got to have pumps that help move things along pipelines. So it's way out in the middle of the Arctic or tundra or somewhere, and this thing can get on with it, but it's a gentle usage. And you're never going to go water skiing with a Stirling engine, really. And even Ericsson's engine boat, the monster ship, you know, it did 12 knots or something. And it was instantly discarded because steam engines could do 15 knots. It was far, far cheaper to shift the cargo because of the efficiency of the engine. Even Ericsson's hot air, I don't think there was regenerator on that one, but cheapness didn't count, speed counted.
That's great, thank you. And we've just got time for one more question from Alex Rowe, saying, interesting talk, Andrew. These microgen engines, are they used in Germany to heat homes as well as to air condition them? That would seem like to be like an ingenious idea.
Yeah, they are used just for heating. So they're not using the cooling side of it. But I think there's an application for liveaboard canal boats, of which there's quite a lot nowadays in our country, because they're trying to live off grid largely. And we could have a Stirling engine providing some heat in there, which is what Microgen are up to. Likewise, Whispergen did it, well, Don Clucas in New Zealand set up a business to produce a generator for yachts. Because if it's terrible, if you're holed up in Monaco because the weather's terrible, having a steel hull with a clanging diesel keeping your generation going, it's unbearable. So he came up with the Stirling engine called a Whispergen, which trickle charged your batteries and provided some hot water. So I've gone off piste a bit. So remind me of the question again. Oh yes, air conditioning. No, not really for air conditioning.
Okay, thank you very much.
Okay, well, if I could draw this session to a close, I mean, obviously, our great thanks go to Andrew for his very interesting talk, but I also must thank our trustee, Kathy, for all her work in pulling this together tonight. It's been a bit of a trial. I think, I hope you'll agree, it's been a successful trial, and we're planning to do a few more of these over the next 3 to 6 months. If you have any ideas for topics that might be of interest, please do drop us a line and we'll see what we can factor in. So hopefully it won't be too long before we're able to welcome the Stirling Engine Society back to the museum. Next year will actually be the 10th anniversary of their first event at the museum. So we'll try and make that something a little bit special for having missed out on this year. But until then, one and all, stay safe and hope to see you all soon.
Thank you.
Thank you and good night.
Thank you.